Chapter 8. We covered 8.2. Alright, paying attention. You can still eat, it's okay. 8.2 was, we say SR standing for short run cost curve. Which we did last night. 8.3 is long run cost curve. And this section 8.3 is very good for a midterm question, which is, what is the main difference between the short run cost curve and the long run cost curve? All right, let's draw the picture. And the short run cost curve had a fixed cost. So it began when its quantity is 0. Here is the cost. It began somewhere up because of the fixed cost. And then it was rising steep, then flattening out, and then rising steep again.
Can I ask a question, sir?
Yes.
Usually when we draw a graph, you ask to write an explanation, not just draw. Even
Yes.
for this question,
Yes.
you will have to
Yes,
explain.
you have to. Yes, of course, you have to explain. Again, the fundamental premise of education is, if you can't explain it, you don't know it. That's one of the fundamental assumptions of Western education. The Western education is extremely unacceptable to say, I know it, but I can't explain it. Usually that doesn't happen. We don't believe in this. We think this is impossible. If you know it, and if you understand it, you should be able to explain it. If you can't explain it, it means you don't know. All right, so coming back to this part over here. I can use another color here. All right, I can use the green color. Here, the long term begins right at 0. Why? In the long run, there are no fixed costs. If you need to produce 0 coffee or 0 tea or 0 anything, you don't have fixed costs. You can eliminate in the longer run fixed costs. Second, here, these rise very rapidly. In the long run, they rise not quite as rapidly, a little more smoothly. Okay. Then in the long run, again, you enjoy a much longer period of, we call this part, remember, the economies of scale part. And then in the long run, costs don't rise as steep. And in the long run, costs are always lower than in the short run. Or at least they're never higher than the short run. So at any point in time, the long run is at least a little bit below than the short run. In other words, in the short run, you have certain fixed costs which introduces a little bit of inefficiency. In the long run, you can adjust the fixed costs always for improvement. You can add a little extra space if you need it, or cut down on the extra space. You can adjust all of your fixed costs to make them more optimal. In other words, to lower the overall costs. Okay, so in the long run, it's lower. It's also a little bit flatter. Costs don't rise as rapidly. You enjoy longer, meaning for a larger quantity. In other words, here you enjoy the economies of scale of rapidly falling, meaning very flat curve. You enjoy a short range. Here you enjoy a much wider range because you can adjust more readily in the long run. And we see, we call this short run. Short run total cost. And this is green color. Long run total cost. Now, in the textbook, they say LTC. LTC. And here they say STC. Right?
Can I ask you?
Yes, of course, that's why I'm here.
Now, if I have the same question, what's the difference between short run and long run cost curve? I would say that the cost of the long term run is lower than the
Well, the first difference, which I began with, was that in the long run, there are no fixed costs. In other words, the long run curve begins straight from zero. Okay, so that's the first main difference.
no cost.
That's the first. I'm not saying what you said was incorrect. I'm saying this is the first obvious difference. The second main difference is that in the short run, costs rise very steeply. In the long run, they rise, but not as steep, not so fast. In other words, in the long run, you can increase quantities with lower marginal cost. You can improve, you can add extra quantity without the steep, we call these initial costs. These are initial costs, okay? So that's the second one, difference. The third difference, I already explained it over here. So here, this is difference. Okay, colors. Okay, this is the number one difference is right here. Number two difference is not as steep. Number three difference is that this range of high efficiency is much wider. In other words, in the long run, you can produce efficiently over very wide range. Okay? And the last piece is, again, in the long run, the cost curve rises, but not as steeply. In other words, in the short run, you have huge inefficiencies at the small scale because the costs rise extremely quickly, and huge inefficiencies at the large scale. In the long run, you can adjust to those inefficiencies. In the long run, whether you're in the small range or in the very high range, you can adjust your business so that costs don't rise as rapidly. Okay. So a different way of saying it is, in the long run, costs always rise slower in general. All right, and that is a very good explanation and very short explanation of the long run. Again, they have a lot more stuff. Now here we have one other fundamental concept, the concept of planning horizon. And planning horizon is essentially what in business people mean by long term. Planning horizon is the period over which, again, it's the same definition. Businesses can adjust their fixed cost sufficiently to improve their overall efficiency. So planning horizon, let's say, for example, this university, as it is now, needs to have a planning horizon, maybe 3-5 years, to say, if we will grow more than 20 or 30% the number of students, we will need extra classrooms, and we will need extra parking, and we'll need extra this, and this. In other words, they'll need a list, and they'll need to address those needs, okay? The planning horizon includes all fixed costs as well as variable costs, like teachers, how many teachers we're gonna need, okay? The trick in the planning horizon, this level of inefficiency is usually called in business, in management, a bottleneck. A bottleneck is a necessary process, a necessary element in the business for which the business has at some point experiences serious restrictions, okay? The most common bottleneck for big businesses, like I'm experiencing in Dubai Mall, is parking, right? At one point, let's say on Fridays, early afternoon, it gets hard to park, okay? Bottleneck not yet present here, but if this university will double, will certainly be parking spots here too, right? Now it's not yet a problem, and the university could grow maybe 10, maybe 20, maybe 30%. In other words, we might be somewhere over here on the curve. And here is where you get these bottlenecks. See, these bottlenecks represent or impose inefficiencies on a business. Example of a bottleneck will be a very good restaurant, okay, which has only limited space, and the result is that the tables are all full, and people just sit outside and wait, okay, and they can't increase the number of tables. Or the restaurant is very good. Next thing is they increase the number of tables. They say double the number of tables. But the restaurant is really good because they have a good chef. But you can't just double the chef easily, okay? If the chef is unique in, I don't know, Japanese cuisine or Korean cuisine, you can't find a second expert in Japanese cuisine, let's say, outside Japan, easily, okay? So suddenly there will be one bottleneck, whatever it is, let's say classrooms, you resolve it, but then there will appear a second bottleneck, the parking. Then there will appear a third bottleneck, let's say, here in this case is teachers. For example, one of the biggest bottlenecks in MBA programs is finance professors, and there's a reason for that. Financial management is usually the hardest of all MBA courses. It's the hardest of all business courses in general, and most people hate it, okay? Well, the natural result is that most people don't go into finance because it's too hard. And in general, everybody wants to go into what?
Economic maybe?
No, no. Definitely not economics. Economics is the second hardest, and a lot of people will say it's even much harder than accounting. Accounting is straightforward in many ways. It's a debit and it's a credit. It's a debit and it's a credit. And you can, over time, learn these are the debits and these are the credits, okay? So accounting has what's called a limited scope, okay? Over time, you get to learn the debits, you get to learn the credits. In accounting, you get only so many assets, okay? And that's the end of it. And then you get so many liabilities, and that's the end of it. And at one point, you can learn accounting from end to end, not with economics. Economics is much harder. But the easiest one is marketing, okay? So everybody goes into marketing, and everybody goes into human resources, and nobody goes into finance and financial management. Well, the result, of course, is that you got 10 times more people in marketing and marketing and human resources, and you got 10 times less people in finance. So you get over time, over the decades, shortages of finance professors. So trying to find a finance professor is very hard, extremely hard, especially qualified. So again, you can easily grow the program, but at one point you're going to hit parking. You solve the parking, you're going to hit classrooms, then you're going to hit the problem of finance professors, okay? So there's always, as you resolve one problem, there will be of size and scale, there will be always the next problem. When you solve the next problem, there will be always the next problem. So that's why the curve always rises, but in the long run, not as steep. Okay, so that's the planning horizon. In the planning horizon, the business always plans for the long run. And in the planning horizon, 3, 5, 8, 10 years, you want to make adjustments for all fixed costs and for all capital expenditures. All right. And I already discussed 8.4 a little bit. Now I have a little bit more. 8.4 is economies of scale, and actually call it plant size. Plant size and economies of scale. Now, economies of scale has two very different definitions, which appear to be, which are actually in a sense the same. Economies of scale. The first definition, we covered it before. What was it? Anybody? We covered it already. Economies of scale, right? This is the same as increasing returns to scale, okay? When you double inputs, output more than doubles. So output grows faster than inputs. Output grows faster than inputs. Grows faster than inputs. Okay. Well, what does it mean? It means that if inputs grow at a certain percentage, this means that exactly at the same percentage your cost will grow. But output grows faster. So the average cost will be actually falling. So that's the second alternative definition. It follows from the first one. Falling average Okay, so falling average cost is equivalent to output growing faster than inputs. For example, you increase inputs double, output will triple. Per unit cost will be falling. Okay, because the cost doubles, but the output triples, so the average cost the cost will double, but the average cost will fall more. So this is a very simple and straightforward. Okay. So increasing returns of economies of scale will mean a falling average cost. Okay, and the average curve goes down. So as long as the long run average curve goes down, you have economies of scale. That's number one. Now, decreasing, or we say before, economies of scale, which means the same as decreasing returns to scale, means that the long run average cost, the average cost is rising. We say here average cost falling. Again, I covered it before. Let's say what are the reasons for economies of scale? We did it before. Number one, division of labor. Division of labor means you will do only this, and you'll do only that, you'll do only this, you will do only that. So one person is doing fewer things, which means higher productivity. Goes up. Second, it goes up together with division of labor is specialization. Again, productivity rises. The third one, this is again specialization here, I mean of labor. People will specialize. One person will specialize in accounting only. A second person will specialize in marketing and advertising. A third person will specialize in finance. A fourth person will specialize in IT. A fifth person will specialize in whatever, something else. Another person will specialize in production. Okay, here one teacher specializes in one subject, the second teacher specializes in the second subject. A third person will specialize in library. Okay, so and number three is similar to number two, specialized equipment. Specialized equipment, specialized machines. Yes, in general, technology. Overall. So you're going to have a very particular type of machine, particular type of equipment. For example, it's one thing to build buildings, 2, 3, 5, 10 floors. It's a completely different story. Building a 100-story skyscraper. Okay, the skyscraper will require specialized cranes. okay? It will require a lot of specialized technology, okay? Example. I was watching about a documentary about Burj Khalifa. Well, bringing the water up to the top floor is not easy. It is so high, I don't know, kilometer high, that if you just pump it from below, it doesn't work. You need such a pressure at the bottom that the pipes will just burst completely. So it's impossible. They actually, you don't need to try. You have an engineer who tell you, no, it doesn't work. So what they do is, as the building goes up, high to the sky, at the floor, let's say 25, they make a huge reservoir of water. So they pump from below, they pump to the reservoir here. They pump only 20 floors, that's it, no more. Then they take a second pump and pump another 20 stories or 20 floors up here into a second reservoir. So you fill up the reservoir here, okay? Then you suck from here up through pumping again. So you're pumping only 20 floors up. Again, this is an example of, again, extraordinary engineering specialization into, it's not a straightforward just to push it up 50 floors. The pressure is phenomenally high, okay? You can't hold. And again, you gotta keep doing it every 20 or so floors, okay? Because the pressure in a vertical pipe depends only on the height, okay? It doesn't depend how wide it is or whatnot. Again, this just provides examples. So you need a whole bunch of specialized technology, even, here's another word here, specialized technique. Technique is the same as process. In other words, the standard stuff doesn't work. You need to modify standard stuff. So that's another reason. Now, as firms grow bigger, as firms get bigger and bigger, and you manage more and more, per unit, for example, you can double the size of Lulu, you will have fewer supervisor per employee. So fewer supervisors. All right, as the business grows, you can have, let's say, a slightly bigger accounting department, and instead of having 3 accountants with 1 manager, you can have 7 or 12 or 15 accountants with 1 manager, okay? Similarly, with departments, you can have, let's say, 30, 40, 50 professors with only 1 dean, okay? Not 10 professors with 1 dean. So as you increase the size, you get fewer supervisor per employee, or per output. Next one is fewer spare parts. Of course, when you grow the business, the size, the number of spare parts will increase, but it will not increase as fast as the business. So, if before you need to hold 10% of spare parts, if your business grows, you might be holding only 8. And if the business gets bigger, you might be holding only 6%. The absolute number increases, but percentage-wise, it falls. And spare parts represent the cost. Same thing is fewer inventories. Just a second. Fewer inventories. So fewer supervisors means, okay, I forgot here to write. Let me write here. Specialized equipment, machine technology, and techniques mean increased productivity. Here, fewer supervisors means lower costs per unit average cost. Falling, again, this is as in falling average cost. Fewer spare parts means again lower cost, and fewer inventories means lower cost. Someone had a question? Yes?
What the name of spare?
Spare means extra, additional, just in case you need it because it breaks. For example, you have a taxi company and have 200 or 300 taxi. Okay? And these taxis drive a lot. So you will be changing tires a lot. If you're changing tires, you need to keep spares the same as extra tires, just in case. Same thing, if you're running your taxi, you will need to change oil. You'll have to have oil, engine oil. You see? But if you have 10 taxis, you keep one size of extra spare oil. But if you increase the taxi to 100 times, the oil, you don't need to increase it 10 times. You can increase it only 2 or 3 times. Okay. Questions? Yes?
I was thinking that inventory is the same as the spare. Why did you put it in two separate points?
Yes. It's actually true and not true. Correct. Inventory will be, if you're studying accounting, will be for raw materials, okay, will be for intermediate, and the third one will be final products. This is the standard classification, okay? The intermediate one they call in accounting work in process. So when you count spare parts, yeah, you can count them as kind of like raw material, but maybe not, okay? You can count it as intermediate. But usually when they say fewer inventories, they mean you keep less of the final products, okay? So spare part is an inventory associated